Welcome to Sparrow Psychology.
Have you ever just stopped and wondered what is actually happening inside my head right now? I mean, what is that 3-pound supercomputer doing that lets you understand my voice, see what's on the screen, and hopefully learn something new?
Well, today we're going to take a peek under the hood. In just the next few minutes, we're going to break down some incredible insights from neuroscientist Dr. Andrew Huberman to figure out how that amazing organ makes you, well, you.
All right, first up, let's talk about a sense we rely on all the time, vision. It feels so simple, right? You just open your eyes and see. But the journey from a little bit of light to a full-blown conscious image, well, that's just extraordinary.
So, how does it actually work? Well, think of your eye like a camera. Light comes in and hits the retina at the very back. Now, this is where the real magic starts. Tiny photoreceptors, kind of like the film in an old-school camera, turn that light into electrical signals. From there, specialized messenger cells fire that information off to your brain, where the cortex pieces it all together into the world you see. And that film in your camera? It has two main kinds of light detectors. You've got your rods, which are the absolute masters of seeing in dim light. They're the reason you can find your way around a dark room. And then you've got the cones, and they're your color specialists. We have 3 types, each tuned to different wavelengths of light, and your brain compares the signals from all 3 to paint your world in brilliant color.
You know, this brings up a really fascinating question. Even though the biology for seeing color is pretty much the same for all of us, we can never really know if your personal experience of the color red is the same as mine. It's a wild reminder that our reality is something happening entirely inside our own heads.
But here's the thing, vision isn't just for looking at stuff. Your brain also uses light for a whole bunch of hidden autopilot functions that you're probably not even thinking about.
So get this, deep inside your brain, there's a teeny tiny cluster of cells called the suprachiasmatic nucleus, or SCN. This is your body's master clock. It's the central pacemaker that keeps the 24-hour rhythm for nearly every single cell in your body, telling your organs when to power up and when to rest.
And how does this master clock know what time it is? Light. It's that simple. When bright light hits your eyes, even if it's the middle of the night, it sends a super powerful signal straight to your SCN. And that signal, to put it bluntly, slams your melatonin to the floor, instantly stopping the production of your sleep hormone. It's a direct line from the outside world right to your internal chemistry.
And here's another one of those hidden systems, balance. Ever get sick trying to read in a car? That's what scientists call a visual vestibular conflict. Basically, your eyes are telling your brain one story. Hey, we're looking at a stable phone, nothing's moving. But your inner ear, your balance system, is telling a completely different story. Whoa, we are definitely moving forward. Your brain gets these 2 conflicting reports, and it does not like it. The result? Nausea.
Okay, so our brain sees the world and runs our internal systems. But how does it actually control our actions? Let's take a look at the brain's control tower. Let me introduce you to the cerebellum. People call it the little brain, but a much better way to think about it is as an air traffic control system. It doesn't actually start any movements, it's not the pilot, but it coordinates and refines them with incredible precision. You know, learning to ride a bike or swing a tennis racket? That's your cerebellum working overtime, correcting all the little errors until your movements become smooth and totally automatic.
And right next door, you've got the basal ganglia. This part acts like a gatekeeper for your actions, constantly weighing go signals against no-go signals. Think about the famous marshmallow test. The go signal is screaming, eat that marshmallow right now. But your no-go circuit, with input from your higher-level brain, is saying, wait, hold on, if we just wait a minute, we can get 2. That internal battle, that's your basal ganglia at work in literally every decision you make.
So we've seen how the brain sees, how it keeps time, how it acts. But maybe its most incredible feature, its ultimate superpower, is that it can actually change itself.
To really understand this, let me tell you a true story. There is a woman, blind since birth, who is a brilliant executive secretary, an absolute master at reading Braille with her fingertips.
Then one day, tragically, she had a stroke. When the doctors looked at her brain scans, they saw the damage was only in her visual cortex, the part of the brain dedicated to sight. So the neurologist told her, hey, good news, the stroke was in a part of your brain you weren't even using.
But he was completely wrong. After the stroke, she could no longer read Braille at all. And here's the mind-blowing part. Her brain, since it wasn't getting any information from her eyes, had cleverly rewired itself. It took that unused visual cortex and repurposed it to process all the complex touch information coming from her fingertips.
Her brain was literally seeing through touch.
And this amazing story is a perfect example of what we call neuroplasticity. Your brain isn't some fixed piece of hardware. It's dynamic. It's living tissue that can reorganize its own wiring based on what you've experienced. It's this general-purpose machine that can repurpose its own valuable real estate for whatever job is most important.
So just think about what we've covered. The brain inside your head right this second is turning light into your reality. It's running a secret 24-hour clock that's set by the sun. It's acting as an air traffic controller for your every single move, and most incredibly of all, it has the superpower to completely rewire itself. It's not just a machine, it's a living, adapting universe.
So hey, if you enjoyed this quick tour inside the brain, please subscribe for more explainers just like this one, and share it with someone you think would find it fascinating too. Thanks for watching Sparrow Psychology. We'll see you next time.